Hey guys, how you doing? Today we're going to do 6.3 multiplying and dividing rational expressions. So there's a couple things we need to remind ourselves. First of all, when we have multiplication, remember that we multiply the numerator and multiply the denominator. So we have AC all over BD. Now with division is the same thing as multiplying by the reciprocal. Remember, reciprocal is like flipping that. Okay, one of the biggest notes, do not cross multiply. That will come into later when we are solving, but not with multiplying and dividing. What we actually do is we take our division and we're going to switch it to multiplication and then flip that fraction or that rational function after the division sign. Okay, and then we're able to multiply now straight across. A times D all over B times C. Okay, those are two things to keep in mind first. The other thing we're going to do then is once we multiply or divide, we're going to factor to see if anything crosses out. So this is also why we did a factoring worksheet before. So remember to do your GCF first, your greatest common factor. Factor normally, which of course is our ax plus bx plus c. That should be ax squared, right? Which actually is down here. I would just focus on the one down here, guys. And luckily, we have directions, so don't worry about this one, okay? And then we need to also remember that we have a special factoring, which is the difference of squares, a squared minus b squared, and that's just taking the square root of a and b, one's addition and one's subtraction, okay? So here's an example for you, and then we're going to practice some together, okay? So as we can see that this is a division. So our first step is actually to change it to multiplication and then flip the two. See how they're flipped? All right. Next, we factor. Now, many of you will have to do this factoring on the side. You'll see as we go through examples. Once we factor, we see if there's something on the top that is the same on the bottom, we can cross it out because something over itself is always the value of 1. Okay? So as you can see, after I cross out the x minus 5 and the x plus 1, we are left with x plus 2 on top, x minus 3 on top, and x plus 4. One of the things that will happen in your homework is that they actually want you to add something onto this. They want you to remember what you crossed out, because what you crossed out cannot exist. So x cannot be, well, what makes x minus 5 0? That would be 5. X cannot be, what does x plus 1 equal 0? Negative 1. These you'll find out in graphing are your wholes. Okay, so what you crossed out is your wholes. And we'll go over that later. But for now, just remember, anything you cross out, set that equal to 0 and solve. Because that's what x cannot be. Okay, so we're going to do that now. All right, what do you guys notice? Right away, I noticed that this is division. Oh, this is the wrong one. Sorry, why am I going to a harder one? Okay, multiplication. Now, this we don't really have a factoring, but we have a crossing out. Some of you might want to do this by expanding everything. So multiplication means we're going to multiply straight across. 3 times 8 is 24. X squared times x to the 5th. X squared times x to the 3rd. We add the two exponents, we get x to the 5th. But what I'm going to do is I'm going to expand this so that way it's easy for me to cross out. If you know of a shortcut, use it. I'm not going to give it to you. I want you to find that out. Now we have 1y, 1z, and that's on top. So on the bottom, 2 times 15 is 30. No x's. We have 2 z's and 3 y's. All right. So one thing I want to show you that most people forget is that they forget to simplify this fraction. Many of you can do this by just plugging it in on your calculator and making that decimal into a fraction. I'm going to do it without one so you can see. I know a factor that goes into 24 and 30. The biggest one would be 6. So 24 divided by 6 is 4. 30 divided by 6 is 5. And now we see that 4/5 cannot be reduced anymore. I also see none of the x's can be canceled, but there's one y here that can cancel with one y here. There's one z here that can cancel with one z here. When I'm done canceling, I'm able now to write my final answer, which would be 4 on top. And how many x's do we have? 5. So x to the 5th all over 5. That's z to the 1st. I don't have to put 1 in if I don't want to, but I have y squared. And we're done. All right, let's do a problem just like that, but with division. Because we have to remember the first thing we do with division is to change it into multiplication. Now, changing it into multiplication means I keep the first fraction the same. 7xy cubed. I change it to multiplication, but then what do I do with the second fraction? I flip it. I do the reciprocal. So I have the 7x to the 6th, y squared, z to the 6th on top. And on the bottom, I have 15x y cubed, z to the 8th. Now I'm going to do exactly what we did above. I'm going to multiply everything out. I'm going to write and expand everything. Then I'm going to cross out. 3 times 7 is 21. X to the 6 times x to the 6 is x to the 12th. I know this is long, guys, but I would rather expand it and make sure I'm not making mistakes. If you know the shortcut, do it. 5, 6, 7, 8, 9, 10, 11, 12. Okay. Y's. Don't forget here, I have this is y to the 1st. This is y squared, so y cubed. So 1, 2, 3. Also be careful, those of you with bad handwriting, make sure your x's and y's are different. Z squared times z to the 6th is z to the 8th. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's my numerator. I know this looks very funny, but I want to expand everything. 7 times 15. Well, I know that most of you don't know this by heart, which is fine because neither do I. So 105. Use your calculator when you need it. All right, let's look at my x's. Don't forget, this is x to the 1st, this is x to the 1st. So I have 2 x's. Y cubed and y cubed is 6 of those y's. 4, 5, 6. And then z, I don't have any here, but I have 8 here. So 1, 2, 3, 4, 5, 6, 7, 8. All right, so what can go into 21 and 105? If you guys look here, you both have a 7, so I know 7 goes in there. And 3, well, 15 can go into 15. 3 can go into 15. So let's see, does 21 go into 105? 105 divided by 21 equals 5. So yeah, 21 goes into both of these. 21 goes into 21 one time. And 21 goes into 105 5 times. Now, guys, let's just say you were like, well, I'll try 7. And if you plugged in 7 or took 7 out for both of those, you would get 3/15. Just make sure there's not another common factor to take out, okay? Now, x's, I have 2 down here that I can get rid of with 2 up here. Y's, I have 3 up here, and I can get rid of 3 down here. And what happened to all of our z's, guys? There's 8 up here, 8 down here, so they're gone. And let's finish this up. Do you have to put 1? No, you don't. But how many x's do we have up here now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have x to the 10. Nothing else up there. We still have that 5 in the denominator and 3 y's below. Wow, that's a really small answer for that big division problem. And we're done. Okay, those are just your basic multiplication, but now we've got to get into that factoring bit. I notice that this is multiplication, so I'm not going to flip it. I'm going to keep it as is. But after I do this, I need to factor its parts, okay? So x plus 1, I see that x plus 1 cannot be factored, and that stays. X plus 4 cannot be factored, and that stays. But if I look at this numerator here, what do they have in common? They have a GCF. They have an x in common, so I'm going to factor that out, leaving me with x plus 4. And then on the bottom here, I have an x plus 2. All right, what is the same on top that is on the bottom? Now, I want to point out to you one more thing. Do you guys see how I put parentheses around here? Because I can't cancel out a part of that. I have to do the whole thing. So even though you're like, well, there's an x here and an x here. No, you can't. Because this x has an attached plus 2 to it. So you can't cancel it out. You can only cancel it out if it looks like each other, which, as you can see here, is this x plus 4. So on top, I'm going to put this x in front because that's usually how we label it. We're also left with an x plus 1. And on the bottom, all we have is an x plus 2. We're quite not done yet because remember, we're going to point out something. We're going to point out what we crossed off. And that will tell me what x cannot equal to. So on the side, I'm going to say x plus 4 cannot equal 0, and I solve. What makes that equal 0? Negative 4. Okay. All right, another multiplication, so we don't need to flip, but we're going to have a little bit more factoring here to do, okay? What I want you to see is that this is x squared minus 2 squared. Remember that was your a squared minus b squared, the difference of squares. So when we factor that, the square root of x squared is x. The square root of 4 is 2. And 1 is plus, 1 is minus. So I'm going to label this difference of squares on here. That's why I factored that. On the bottom, they have something in common. They have a GCF. So I'm going to take out a 2 there, get x plus 1 times. Now I'm going to factor. Many of you will have to factor on your side, right? I can do this, x squared minus 2x minus 3. Remember, a times c, so 1 times negative 3 is negative 3. What two numbers multiply to give you negative 3 but add to give you negative 2? That would be negative 3 and 1. Make your box. A term goes here, C term goes there, your other two numbers, and attach that X onto it. Now factor out what's in common. X squared and negative 3x. What do they have in common? They have an X. Now I can think of multiplication. X times what is X squared? X. X times what is negative 3x? Negative 3. X times what is X? 1. And then I can make sure negative 3 and 1 right there. Okay, so I'm going to factor that out. So I have X plus 1 times X minus 3. And that is our top. Okay, the bottom. What I want you to do is, if you're iffy about your factoring, okay, I want you to pause the video, factor this out, and then I'm going to give you the answers, okay? Because we should have practiced enough factoring of this that I can focus on the multiplication and the division, okay? So pause if you have to right now. All right, so when we factor this out, we get X plus 2 times X plus 2. All right, now what do they have in common on top and bottom that I can cancel? Well, I have an X plus 2, so I can cancel that X plus 2. I have an X plus 1, so I can cancel that X plus 1, because one's in the numerator and one's in the denominator. Be very careful with that. So what are we left up on top? We're left with an X minus 2 times an X minus 3 all over. We're left with a 2 and an X plus 2. What do I need to remember? I need to remember to include what we got rid of. So X cannot equal, well, let's look at this one first, X plus 2. What makes that 0? Negative 2. And on the other one, X, what makes that 0? Negative 1. And we're done. All right, just 2 more examples, just so we can make sure we have this down. What do you guys notice right away? It's division. So we have to flip it first. So here I'm going to get 12x minus 20. Remember, because that first fraction stays the same. Multiply, but I'm going to flip the rest of it. So it's 3x squared plus 14x plus 15 all over 9x squared minus 25. I want you guys to notice, in this numerator, we have something in common. So in other words, a GCF. We have basic factoring, and here we have the difference of squares. Okay, so I'm going to factor each part. What's common between 12 and 20? Make sure it's the greatest, because many of you might say 2 right now, but actually there's something more, and the answer is 4. So you get 4 times 3x minus 5 all over. Pause right now if you want to check to see if you can do this. Otherwise, I'm going to do it very quickly. You get x minus 7 times x plus 3. Okay, what I will do and show you, because we have a bigger one to do, so I want to make sure that you guys have this down. Remember, it's A times C, so 3 times 15 is 45. What 2 numbers do you multiply to give you 45, but add to give you 14? Okay, if you don't know the factors, make sure you write them down. That would be 5 and 9. Let's do our box. This is 3x squared. That's our A term. Our C term is 15. The other 2 numbers, add an x to it. All right, let's see what they have in common. So across here just has an x. x times what is 3x squared? 3x. X times what is 5x? 5. 3x times what is 9x? 3. And let's make sure those add up together or multiply together. 3 times 5 is 15. All right, let's write that in there. So on top here we have 3x plus 5 times x plus 3. All over. Now this is the difference of squares. Remember, we can do this quickly by taking the square root of each piece. What is the square root of 9x squared? Well, what times itself is 9x squared? 3x. What is the square root of 25? 5. Remember, one is addition and one is subtraction. Okay, let's cross some things out if we can. All right, so I have a 3x minus 5 crossing out. I have a 3x plus 5 crossing out. Woo! And I have an x plus 3 crossing out. Because again, they are on different levels. So what am I left with? We are left with 4 on top and x minus 7 on the bottom. Don't forget to write in what was crossed off. All right, so of course the easy one is probably this x plus 3. What makes that 0? X cannot equal negative 3. Now the other ones is where you might want to do that side work and solve. Okay, so I would subtract 5 and divide by 3. So x cannot equal negative 5/3. We have one more though. We have the 3x minus 5. When you do that algebra, you get x cannot equal 5/3. So in this case, we have 3 things to remember. How are we doing? All right, and of course, they're going to give you something complicated. Now, I see the first part is multiplication. Second part is division. The only thing we worry about right here is that division, the fraction after the division, which is this one right here. So what I'm going to do first is keep the other two the same, because all I want to do is flip the fraction that is right after the division. Okay, and I point that out because if the division was the first one, we would just be flipping that second fraction there. Tons of factoring, huh guys? Yep, right there. 4 minus 12. Now times, don't forget to flip. 10x squared plus 40x all over x squared minus 4x minus 21. Okay, guys, so just to tell you, I am going to do factoring quickly. If you want, pause it right now. Try to factor everything you can, see if you got it correct, okay? Because all of these things, I'm going to try to factor. This one I see is a greatest common factor because 10x squared and 40x have something in common. And so does this one. So I'm just leaving myself a note just in case. All right, so on top, I get I'll get x plus 3 times x plus 2. Again, guys, pause if you want to try your factoring to make sure you have it right. On the bottom, what they have in common is a 5. That's x minus 1. Then multiply. Sorry, I'm humming. I'm doing this factoring in my head. Again, do it on the side if you have to. On the bottom, we get x. Let's see, that should be 6 and 2, but that doesn't. Yes, 6 and 2. on the top here, they have in common at 10x, leaving us an x plus 4 all over, and then on the bottom we get x minus 7 times x plus 3. Okay, again, if you have to, go do your box stuff and see if you got those correct. See what we can cancel. Remember, we can only cancel things that are on the top and the bottom. So see how we have an x plus 3 on top? Right here, both of these. I cannot cancel both of these. But what I can cancel is this one with this one, or this one with this one, but not all three of them. So cancel. Let's see, what else do we have that we might be able to cancel? Oh, I see an x plus 2 on top, on bottom. Anything else, guys? I don't see anything else. So, and see what the answer is. So on top, we have a 10x. We have a x plus 4. We have a 2x minus 1. And an x plus 3. Ooh, that's a long one. Let's see. We have on the bottom a 5. Ooh, I want to show you something. As I need you guys to look at this last step. See how I wrote this? This is not simplified all the way yet because look at that 10 and that 5. What goes into both of those? 5. How many 5s go into 10? 2. How many 5s go into 5? 1. You don't have to put the 1 out if you don't want to. And then what do we have to add on to this? We have to add on what we crossed out. What makes this 0? So x cannot equal -3. What can that not equal? -2. Okay, so we are all set to do some practice with big ideas.